Oh, all right. Greetings, wonderful people. So let's see what we got today. Solve systems of equations by graphing and solve systems of equations by using the substitution method. All right, so we're going to kind of, so we already worked on graphing. So we already know a couple of things like the y equals mx plus b, and start with the b value. So what we're going to need to know for this one, for this new lesson here, well, first off, we're going to need to know what a system of equations is. So again, equations are the y equals mx plus b, and we want to know, like if I have two of them, where are they going to meet up at? Or where can they meet up at? And that would involve two or more linear equations. Now, looking at a graph, this is probably one of the easiest ways to find them. And these are the three different kinds of solutions that you can get. So the first one is a one solution or single solution. And that would be right there where they intersect. So the intersection is where the solution would be. Now that's where, like for x and y, remember that there's always an x and a y value. It's where x and y can be equal to each other, so where they can basically meet up at. And then over here we have a no solution, so there is no intersection. Remember that parallel lines do not intersect. So since these parallel lines do not intersect, there is no spot where x and y can make both equations equal to the same thing. And then lastly, we also have infinite solution. Now it's kind of hard to tell looking at this, but there are actually two lines, one over the other. So they're basically overlap. Some people will call this the same line, but well, whatever you call it, same line, overlapping lines. They're basically, traveling together. They're always going to be true, so that we call that infinite solution, meaning that no matter what we put in there, no matter what we substitute in for x and y, it's always going to be a match. Okay, so let's go ahead and see if we can get some of this going with the exercises. So solve each of these by graphing. So solve each system of equations below by graphing and identify the solution. All right, so there's a couple of things going on. First off, let's go ahead and graph using the same method that we were using earlier. So that's the y equals mx plus b. And as I was telling you, remember, it's just like yesterday, I made excellent breakfast. So start your day with breakfast. Or B is for begins, and that's where your line begins. So I'm going to go ahead and let me think. How can I? I'll go ahead and just use my. I'll just use my normal. All right. So first thing, looking at this, that -6 is where our first line begins. So let's go ahead and mark out -6. So we got to go down 6 from the middle. And then looking at our slope, if it's a fraction, then that means that we use the rise over run. So that means up 5, or actually in this case, there is a negative here. So that should tell us that this is a line that goes down. So down 5 over 3, and that negative can only be in one place. So it doesn't mean go down and then back, okay? Just a reminder, it's gonna look something like -5 over 3 or 5 over -3. So if I go down 5 over 3, which in this case, it would be something a little off the graph. It would probably be like right there, maybe. But let's use a better point. So I used down 5 over 3, but I can also use this one. So again, that negative has to be at least in one spot. So if I move the negative to the bottom number, my top number is positive, so that means I go up 5. And since my bottom number, the run, is negative now, I move back 3. And you can see that I kind of have these three lines going through each other. I can basically connect all three of them. Okay. And make sure when you're drawing a graph or drawing a line on a graph that you go from one side all the way to the other. Okay, because we don't need little lines that go like this. All right, lines do not do that. Lines go on and on forever in both directions. If you need to use a ruler or any kind of straight edge tool to draw that line, then go ahead and use, you know, whatever you can, even if you have to fold a piece of paper. But lines go on forever. Okay, now let's go ahead and graph this second line. So start with the b value. So in this case here, it's 5. So I'm going to start at 5. And then we're going to follow the slope. So in this case here, I have a rise of 1. So I go up 1, and now I have to go over 6. So that's 3, 4, 5, 6. Try my best to go through that line. And again, go all the way to the end of the graph. And now in this case, it is important to get this as precise as possible. Before, if you had a line that was slightly crooked, it wouldn't make much of a difference. But in this case here, if I had my line going like kind of bending downwards, it might cross somewhere over here. Or if it was bending upwards, it might cross over here. But in this case, we need to know exactly where it crosses. So if I look at the line, let's see, going back here, I go -6 and then up 4. -6 up 4, and that is going to be the solution, negative. So I'm going to go ahead and write it as a ordered pair. Let's see, I can put it, I'll put it right here. And again, this is the solution here. That's where both of them are going to be matching up. Okay, so that takes care of that one. Let's go ahead and do another one. So I have y equals 5. Okay, so and if you need to, if you're stuck on one of these, you can use Desmos. But you still have to do the graph. All right, so you might as well just do the graph here. And most of these are not going to be that tough. So this is actually going to be one of those tricky ones because there is no x value. So remember, if there is no x value, that means it does not touch the x-axis, which means it will not intersect with the x-axis. So y equals 5. There is no x, so there is no slope. That means this is actually going to be your y-intercept. So we're going to have a straight, flat, horizontal line that just goes side to side. Because again, there's no slope. It doesn't go up. It doesn't go down. And again, if this might get confused if something was like x equals a number. But again, if there is no x, it will not touch the x-axis. And if there is no y, it will not touch the y-axis. So it'll be parallel to either of those axes, to whichever one it's missing. Okay, now we have y equals 2x plus 7. So this is our second equation. Now it starts at 7. So again, start with our b value. And in this case here, if it helps, we can turn a number into a fraction by putting a 1 under it. So 2 over 1. And that should give us our rise and run if we need it. So in this case here, we have up 2 over 1. So again, up 2, up 1, 2 over 1, like that. And then I'm gonna have to try my best to stay through those 2 points. And if you're working on this, what you can do is go like down to back 1, or let me go ahead and just show you again that you can work backwards, because remember, a negative divided by a negative is still going to be positive. So we didn't actually change any of this. So again, you either have 1 or you have neither or both. So if I go following the line, down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1. So sometimes you'll have to do that several times just to make sure you get the right crossing. So now we can see where these two lines cross each other. And let's go ahead and look at that. So it looks like we go back 1 and then up 5. Okay, back 1, up 5. Now this one's a pretty easy one to check. Okay, so we're done with this problem. We don't have to worry about it, but I'm going to show you again why it works out. So y equals 2x, but instead of x, I'm going to pick -1 because that's our x value right here, plus 7. Oh, and I'm going to need to plug in my y value, which in this case, my y value is 5. And this should balance out. So again, this is the ordered pair, and I'm plugging it into here. And this is how you check it. So 5 equals -2 plus 7. So multiply them together. 2 times -1 is going to be -2. And then -2 plus 7, I get 5 equals 5. And that's true. And if I do the same thing to this one over here, y equals 5, I'm going to have to plug in 5, and that one's a lot easier because I just get 5 equals 5 on this one right here. Because there's no x value, I don't need to plug in anything else. But you notice they both become true. 5 equals 5 is probably as close to the truth as you can get. All right, so again, if you're not sure, you can just plug them in and see if it works out. So in this case, even though, looking at it, it might be a little bit tough to tell exactly where on this graph it is because the graph it's kind of small. Maybe I should have made these a little bit bigger. Oh well, keep going, I guess. All right, so here we have, looks like we have an equation in standard form. So being in standard form, well, we could graph it like this. Well, in order to graph this standard form, we'd have to make each one equal to 0. So make them take turns. So 6 equals 0, and then solve for y. And then do the same with y and make x equals 0. Wait, make y equals 0 and then solve for x. Now we'd probably get a problem there because I can see that we would have a problem doing that. And that is we would have to have the x value divide both by 6, and then we would have 7.5. And it's kind of hard to get it on this graph, so I think it's probably just a much better idea to put this into slope-intercept form. Okay. So let's see, how can we do this? We're gonna have to minus 6x from both sides. And sometimes it's kind of tough to do these things when I have little space. But minus 6x minus 45. Yeah. And now I still need to get rid of this -5 here. So -5. So that means I'm gonna have to divide everything by 5 or -5. Y equals, looks like we have 6 over 5x. And now here we have 45 divided by 5, and they're both negative. And since they're both negative, that means it's going to become a positive, so positive 9. And it looks like we're pretty much done with graphing this one here. So graphing here. So I guess we're ready to graph this then. So to graph it, I'm gonna go ahead and go with 9. Mark out 9 right here. And we gotta follow the slope. So following the slope, we got up 6 over 5. But again, we have that same problem. It goes off of the graph. It would be like somewhere up here, I'm guessing. So instead of making, but again, we know that this line is positive. It has a positive slope. So that means it's going up. So to make it continue going up, we're gonna have to go back this way. See how, look, when I go like this, it's either gonna go up or it's gonna go back this way. But either way I turn it, it's still going up as I move left to right. So again, watch your sign on the slope. So let's try that. Let's go down 6, back 5. And again, these lines are a little bit, so let's see as that works. So we go down 6, that would be 3, and back 5, that would be 5 right here. Okay, and again, we gotta make sure we do this as precisely as we can. And now we need to do the same thing with this side here. So I'm gonna minus 2x from both sides. So 2y equals negative 2x minus 4. And then I'm gonna divide everything by 2. And this should give us our new graph, a new function, sorry, that we can graph. So this would be negative 1x. And then negative 4 divided by 2 would be negative 2. All right, now we can graph this. So mark out negative 2. So again, start with your b value. And this x has a 1 there, so that's going to be negative 1 slope. So it's a negative slope. That means it's going to be going down from left to right. So down that way. Okay, it's going to be going downwards. So it's also good to turn it into a fraction. So it'd be down 1 over 1, down 1 over 1. And again, we got to make sure we get this just right. So looks like we might have our solution right there. But let's see if we can count it. 1, 2, 3, 4, 5. So we got to go back 5, up 3. And that's our solution there, is back 5, up 3. And this is our solution here, okay? The directions tell us to identify the solution. It doesn't say point out where it crosses or anything like that. So anytime you have an assignment like this, you gotta look at the directions and make sure you answer the questions that they're asking. So in this case here, it says identify the solution. We did that right here. Again, we're not just showing where it crosses. It doesn't say just, you know, put an arrow where it crosses. No, it says identify the solution. So that would be the solution for this one. All right, now I think we are done with that one. Let me go ahead and move over to here. And again, it looks like we have another one that is not in slope intercept form. Although this one here looks like you can use standard form graphing to get it, but no, I don't want to do that. It's best to just sort of stick with one way that you know how to do these things. So I'm going to minus 3x. So again, minus 3x like this, and that's going to put it over here. So I'm going to have 6y equals negative 3x minus 12. And I'm going to divide out the 6 so that I can get that y by itself. So y equals, and negative 3x, divided by 6. So I can't divide this, so I'm going to have to end up reducing it. So I'm going to get negative 1/2 x. But this one I can divide because 12 can be divided by 6. That would be 2. So now we have a way of graphing this. So let's go ahead and start with our B value, this lone number here as I call it. Right, that's the one that's not the X. So it's really easy to confuse yourself if you don't put them in the right order. So like sometimes I get students that will, like if they go 3X, here we have a negative 3X, they'd put it on this side and then they'd use 12 as the slope. So basically they switch the numbers. But again, you've got to make it look like y equals mx plus b as much as you can. So let's go ahead and graph this out. So I got my negative, let's see, negative 2 right here. So, and then I got to follow the slope. And again, it's negative. That tells me it's going to go down, right? So as we go left to right, it's going to go down. So down 1 over 2, down 1 over 2. And I'm going to try to keep that pattern up as much as I can. There we go. And then I got to go back the other way, same thing. Make sure I stick through those 2 points. So again, goes through negative 2, and I tried to make this go as close as I could to there. And luckily for us, this one is already in the slope-intercept form. So I don't need to change anything about it. Let's just start graphing it. So negative 5. So again, start with our lone number here, negative 5. And then I got to follow the slope. So down 1 over 2, down 1 over 2, down 1 over 2. Okay, and then extend the line backwards. And again, make sure it goes all the way to the other edge. And again, it's a little bit more important in this case because, well, well, let's finish this up first. Where do they cross in this case? Where is the crossing? The intersection. Now remember, if we go back to that the chart here, if they do not cross, and in fact, this looks like it could almost be the same problem. If they do not cross, then that is no solution. So there is nothing that I can put in for x and y that will make these equations be the same, right? So that I can't make them equal. So that's going to be a no solution problem. Okay, now I was just before that I was talking about making sure you extend the lines all the way across the graph. And I'm going to show you something I see a little bit. And this is something I see probably not like really often, but I'll see little wimpy lines like this, right? And then they'll say no solution because they're not crossing. Okay, but the problem is these lines should cross. This orange line should be going all the way down. So again, that's why I keep telling people, make sure you get that line extended all the way across. Okay, so anyway, let's get back to here. First thing that you got to do is I'm going to, okay, so again, you're just going to kind of do algebra stuff here. But looking at this 2y, I have to get that 2 out of there. So getting that 2 out of there means that I'm going to have to divide everything by 2. So that's what I'm going to do, divide everything by 2. So 8 divided by 2 is 4. And 18 divided by 2 is 9. Okay, not bad. This one here looks like it might require even more work because I'm going to have to minus 24 on both sides. So here I have 4y equals x minus 24. So again, I minus 24 from here. So now I have x minus 24 on this side. And this is just basic algebra. I'm not doing anything weird or out of the ordinary. It's just by now you should be an expert at just doing regular algebra. Next thing I need to do is divide everything by 4. And that should be what I need to graph this in slope-intercept form. So 4 divided by 4 is 1. 1 times y is just going to leave us with y. And don't forget, there is a 1 in front of this x. And we want a fraction, so I'm going to leave it as 1 over 4x. And then 24 divided by 4 is, I think, 6. So I think we're ready to graph this. I'm going to graph the top one as always. So this is going to be 9. Start at 9. And then up 4 over 1. But again, we run into that same problem where I cannot get to the next point. We could guess where it is. But in this case, again, we need to be precise. Because if we're just even a little bit off, the solution might be moved over. Okay, we might have different numbers for that solution. So in this case here, it looks like I'm going to have to go backwards. So again, it's a positive slope, so it's going upwards. Okay, it's going upwards like this. So that means it's going to be going back this way if I continue it back the other direction. So let's go backwards in both directions. So that's going to be down 4. Well, actually, you know what? I'm going to make this a little bit easier, and I'm going to turn this into a fraction. There you go. So I put a 1 under it, and remember that's something you can always do. Put a 1 under it so it can be a fraction. So now it's a lot easier to see my rise and run. So again, up 4 over 1. So I got to go back, down 4, and then back 1. Down 4, back 1. And my line again it's supposed to be going up from left to right. And it is positive, so it's pointing in the right direction. Okay, take a second, look at your line and ask yourself, is it going in the right direction? Because that's like the biggest thing. I'll get students that will do the exact things they need to do, but they will be going the wrong direction, like something like that. Because they're not looking at the slope. They're not looking at whether it's a negative or a positive. You need to look at the slope and determine whether it is a negative or a positive and see which way it's supposed to be going. All right, now I think we're ready to graph the second one. So in this case here, I'm going to start at -6, which looks like we're going to start right there. And then up 4 over 1. So up 1 over 4. My 1 is the top number. And try to get that as clear as I can. Because again, if I'm even just a little bit off, we may not be able to get the right solution. All right, so trying to go back this way here. All right, and in this case, it does seem to work out because my solution is right there. And it does cross the lines nicely, the little grids that we have, showing us where the numbers are on the graph, and that makes it much easier. So let's go ahead and punch in that solution. So it looks like we have 1, 2, 3, so -4, and then we have to go down, and I think I can read that number right there. So I think it's -4, -7. And let me just look at that a little bit closer. -4, and then down 7. Yeah, that looks about right. No, wait, maybe it's 8. No. Okay, hold on.
Please excuse this interruption. We do have a company here working on the alarm system, testing the alarm system. So please disregard any alarms going on. Again, we do have a company working and testing the alarm system. So please disregard any alarms going on. Thank you.
Okay, so I guess that's got to be it. Or I just had to double check just to make sure, because I mean, just looking at the way they cross, it's a little bit of a, is that, you know, kind of doesn't really look exactly like where it crosses, but I just had to double check that. All right, so with this one here, it looks, oh wait, hold on. I was about to say that this looks like it's already been solved for y, but if we look closer, there is a negative there. So that means that that is actually not solved for y. So we're going to have to times everything by -1. And basically that means that we're just going to have to, reverse the sign of everything. So it looks like this y is negative, so we switch it to positive. This is negative, so we switch it to positive. This is negative, so we switch it to positive. Okay, works out. So now it's in y equals mx plus b. So it's ready to be graphed. Okay, so let's see. Let's get this other one done here. Now this one here is a bit of a weird one because if we look at it, it looks pretty much backwards from what y equals mx plus b. Since it looks backwards, we're gonna have to, I'm gonna use reflexive property. And again, we covered a little bit of the properties earlier, like in the very first week of school. And that means that we can switch the side of everything on the equal sign. So I'm gonna make 3y go first. 3y equals 3x plus 18. So again, I just took 3y and moved it over to the other side. That's all I did. We didn't really do any math stuff to it. We just moved it. Next thing we got to do is get rid of this 3 on the y. So I'm going to divide everything by 3. And that cancels this out, which leaves our y by itself. 3 divided by 3 is 1x, or just again, x. Okay, now you might notice that there is something a bit off about this, but let's see what's going on. So start at 6 and then follow the path. Sorry, I meant to point at this one. So again, we have a 1. Now, let me go ahead and just go back really quickly. So we notice that there's a 1x, right? So if I have 1x, so x equals 1x, which is, if I want to turn this into a fraction, I can put a 1 under it. And that's a way that you can turn a number into a fraction so that you can easily find the rise and the run. So again, nothing means that there is a 1 there. So I put the 1 there, put a 1 under it, like any number. Any number can be turned into a fraction by putting a 1 under it. And now I can tell that it's going to be a positive slope of up 1 over 1, up 1 over 1. Try my best to keep that pattern going. Okay, and now time for the second one. So I'm going to need a second line to go down here. And it's going to start at 6. And following the slope, up 1 over 1, up 1 over 1. And we run into that situation that we've seen before of these lines are basically on top of each other. Okay, now if I made them exactly on top of each other, you would only see the orange line. But I kind of put them a little off side. That way you could kind of see that they are, you can kind of see that they're two separate lines there. Otherwise you'd wonder where the green one went. So in this case here, we can get our solution. And that is infinite solutions. Everything I plug in there is going to work. Everything is gonna, in one way or another, match up. So they're always gonna be agreed, okay? They're always gonna agree. Kind of like if you have a good buddy, you know, you might always wanna eat at the same place or something, you know? It's like, oh, that's, you know, I was thinking of eating here. And they're like, yeah, that's a great idea. So it's kind of like that, all right? Whereas sometimes if you're thinking about it, you know, sometimes like people want to have like pizza and you're like, nah, I want Chinese or something like that. So you can only agree on one thing. So you might say, well, okay, if you want pasta, let's just go to Olive Garden or something. So you might have to come up with something else that you still kind of want, but a restaurant that might have both items. Anyway, let's go ahead and move on to the next one. So what do we do for systems of equations where there is no graph? So for this one here, we're going to be using it algebraically. We're going to solve using substitution. So this is what you do when there is no graph. And you can pretty much always graph these. Okay, but it does really help to learn these methods as well. So we got to solve one of the equations for x or y. that means we're going to have to isolate one of the variables. All right, and then substitute. So what we're going to do is we're going to take one and change it a little bit and then plug it into the other. Okay, so again, if you remember the same idea behind having them take turns to graph using standard form, remember that's the one where x and y take turns being 0. It's going to be kind of like that. They're going to take turns working on each other. So again, if like you have no mirror, or let's say that like a firefighter might have to check their suit, but you can't check your suit in the back, so you might have your friend do it for you. So you might have somebody check your suit in the back, the sides, wherever you might have an opening. Make sure all your equipment's running, and then you're going to do the same for him. You're going to have him look over his equipment, or sorry, you're going to look over his equipment, making sure that all the gear is working the way it should, all the air supply, and making sure all the buttons are closed so you don't get any heat inside the suit. So it's the same idea with that. So we're going to take the equation from step 1 and plug it into the other one, into the other equation. And what we're trying to do is we're trying to get rid of one variable. So remember, you cannot solve an equation if you have only one variable. I'm sorry, you can't solve it if you have two, so you have to make it so there's only one. Solve for that one variable that you have. So again, you're trying to get rid of a variable. And then lastly, substitute the answer that you got from step 3 into the original to get the other one. Again, sounds pretty confusing. So sometimes it just helps to just look at it. Just look at the process in action. So here I have two equations, right? And this would be great for graphing it because they're already in y equals mx plus b. They're already in slope-intercept form. So this would be pretty easy to graph, but again, we're not graphing here. It says, the direction says to solve by substitution. So if I just draw a graph and I show where it's crossing, that's not going to work. All right, that did not follow the directions. So to follow the directions, let's go ahead and work on this. So I have this top one. Now remember, this y is the same as negative 7x minus 1. It's the exact same thing. So what I'm going to do, and then this first one's kind of a tricky one because it's like you're kind of, I can understand some people are like, well, where did it come from? Right? And this is also worth the same thing. So if I'm going to take this and I'm going to plug it in for this y, I would get something like this. So I would get negative 7x minus 1 equals, and I have the green one here, so x minus 9. So again, it's a little bit tough to see exactly what happened, but that y, we took out the y and we replaced it with x minus 9. So grab this, plug it in for y. And then from here, you would just solve using your ordinary algebra stuff. So let's see, same thing we're gonna always do. Pick a side for the x to go on. So I'm not gonna bother too much with what is the easiest thing to do. I'm just gonna get to doing it. So that should cancel this x, and that means I'm gonna have to move this 1 over here. And that should give me what I need. So in this case, I have negative 8x equals negative 8. Now I can divide both of these by negative 8 because I want that x gone. I want that x by itself, I mean. And that should give me x equals, and then negative 8 divided by negative 8 would be 1. So I have one part of the solution. Now this would be, let me get my packet out here. That would be step, so we did step 1. We put this in there. And then step 2 was to substitute it and then solve it. So that would be step 3 right here. So now we got to move on to step 4. We're not done yet. In most cases, you're only looking for one answer. And in this case here, that would be our one answer. but we got to find out y as well. So we got to find out what the y value will be. So to find out the y value, I'm going to pick one of my original equations. I'm going to pick the bottom one. It doesn't really matter which one you pick. I think both of them, well, actually, no, definitely both of them will give you the same answer. So y equals x minus 9. But instead of x, I'm going to take x out, and I'm going to replace it with 1. And now I have 1 minus 9, so this is y equals 8. And that's the second part of the answer. So to graph it, I'm sorry, not graph it, to show the solution, I'm going to go ahead and put in my x value. Make sure you put this in order too, because sometimes you may not find your x value first. And it goes in the order of x and then y. So in this case here, it would be, it would actually be -8, because since my 9 is a bigger number, that would make this -8. Almost lost that negative there. But again, that just goes to show that you got to pay attention to those negative signs, because you don't want them disappearing or anything like that. So there you go. And again, that one was kind of a tough one, but I hope I hope it makes sense. So if I were to graph this, it would cross at the point of over 1 down 8. All right, now we got this one here. So I got my top one here. And again, all this here, you don't need to circle it. I'm just showing you. And I'm going to drop it in for this y right there. Okay. So the bottom one, I'm gonna write out the bottom equation, 7x plus 3. And there's supposed to be a y there, but I'm gonna leave it open because I'm gonna put something in there. What am I gonna put in there? I'm gonna put in this thing here, this -5x plus 30. Okay, so I put that in there, -5x plus 30. And I'm gonna just use my, again, regular solving stuff, 7x, and then use distributive property. So 3 times -5 is 15x. And then plus 90 equals 42. And then here I would have -8x plus 90 equals 42. And then from here, I would have, let's see, I'd have to minus 90 from both sides. So minusing 90, I would get -8x equals, and it's going to be a negative number because I'm subtracting 90 from 42, and that's going to be -48. Whew. Okay, now from here, and again, this is just basic algebra stuff. This is why I have to make sure you guys are really good at algebra stuff. And then divide both sides by -8. And I think we should be able to get our x value. So in this case, x equals, so 48 divided by 8, it's going to be 6. So we got our first one here. First value is 6. But again, we're not done just yet. This is only one part of the solution. The other part is that we're going to have to plug x back into one of these. So to do that, again, I am going to have to take one of these original equations. So I'm going to take this top one here. And the reason I chose the top one is because y is already by itself. I don't have to do add or subtract to both sides or even divide both sides or anything like that. I can hopefully just get what I need without having to do a whole lot of work. So -5x, but we know x is now 6. So I'm going to plug in 6 for x. And now I'm going to go ahead and use my just the basic evaluation. So -5 times 6 is going to be -30 plus 30. And it looks like y is going to be equal to 0. So now we have both our numbers, and we can check it by plugging it into one of the other equations, which in this case here, if I plug it in here, and I'm going to do this just really quick mentally, y equals 0. So 3 times 0 is 0. X is 6. So 7 times 6 is 42. So 42 plus 0 equals 42. And that makes sense. It works. So we checked it. And again, checking your work does not mean do the whole problem over again. I get that all the time from students where like, I ask them, do you check it? And they're like, no, because that's a lot of work. No, it only took me like 4 seconds to do it. So you don't have a, you know, you don't have much of an excuse when coming up with these things. There we go. So now we know it works. We checked it algebraically. We could also check it graphically by plugging it into something like Desmos, but we don't really need to. All right, so it looks like we only have 2 more slides to go, and then we'll be done with this. So let's keep moving. All right, so looks like we got another one now. In this case here, they're both in the same form, and it's a little bit tougher to get one by itself. So we're gonna have to pick one, because if we look at this top one, okay, just think ahead, all right? If I wanna get y by itself, I'm gonna have to divide everything by 5. 28 cannot be divided by 5. 6 cannot be divided by 5. Okay, so that's not gonna work. Let's look at dividing everything by 6, because if I wanna solve for x on the top one, I'm gonna have to divide everything by 6. So 5 cannot be divided by 6. 28 cannot be divided by 6. So we can't solve for anything in this top equation. Looking at the bottom one, can we get either of these numbers by themselves? Can I get x by itself? Okay, well, 22 cannot be divided by 7, and 1 cannot be divided by 7. So that only leaves us with one choice, and that is to get this one by itself. And that's exactly what I'm going to do. I'm going to get this number by itself. So the first thing I'm going to do is I'm going to minus 7x from both sides. So again, minus 7x here, minus 7x here. See, I'm going to just put, but now we have it solved for, y. Y is completely by itself, so that takes care of step 1. So remember, step 1 is to solve for either x or y. So we got to isolate one of the variables. So we just did that right now. So now that y is by itself, we're going to take this y and we're going to plug it into the other equation. So my top one is going to be the orange one. So that's going to be 6x minus 5y. But again, we know that y, looking here, see it says right there, y is equal to negative 7x plus 22. So I'm going to go ahead and go here, negative 7x plus 22. So again, I took one and put it into the other. Make sure I put all these in the right spot, make sure I didn't miss anything. Okay, looks okay to me. And then from here, I'm going to have to mesh both of these together. And let's just do our ordinary thing. So I have negative 5 times negative 7. So negative times negative is positive. 5 times 7 is 35. X plus, and then 5 times 22. So 5 times 22 is going to be negative, oops, it's going to be a negative number. That's a negative because don't forget, this 5 is negative, all right? That's a negative 5, not a regular 5, it's a negative 5. So that's going to turn this negative, equals, and then we still have this last number, it's still there, so don't worry about that. Now combine our like terms, so in this case 6 and 35, it's going to be 41 equals, and I'm also going to add 110 to both sides. So plus 110 to both sides, and that's going to be 82. And it looks like it's working out okay, because in this case here, if I were to divide both sides by 41. So 82 divided by 41 would be 2. And that's our first solution. And again, just to show you a few things, this is plus 110 to both sides. And over here, we divided both sides by 41. But again, that's just basic algebra stuff. All right, but we got it. We got one of them. We need the other one. So to get the other one, I'm going to take x equals 2 and plug it back into one of these. It's best to use the original equation. All right, it's best to use the original equation. But in this case, I think it would be a lot easier to plug it into our modified, the modified equation that we had here, because y is already by itself. Now, in this case, we changed so few things. All right, there were so few things changed that we're pretty certain we didn't make a mistake. So that's what I'm going to do. I'm going to plug it into there. So y equals negative 7x, but we know x is 2 now, so I'm going to plug 2 in there, plus 22. And again, you can choose the other one. If I really wanted to, I could plug x equals 2 into this one and then solve for y here, but I'm going to go with this one because, again, it has smaller numbers and it's already solved for y. So there's actually not really a wrong way to do this. So I know, especially with something like this, a lot of students might kind of be on the thought of, well, I can't follow those exact same steps every time, so I can't do it. All right, you don't need to follow the same steps. You don't need to say, okay, well, take the top one and plug it into the bottom one every time and solve this one and plug it only into the bottom one. No, you don't need to do that, okay? Anytime you work on something, you just work on the other thing. So if you use the top one, then use the bottom one next. You know, that's an easy way of making sure that you don't accidentally just keep doing the same one over and over again. All right, and now if you follow the purple, if you follow the purple, I just moved it from here, so all that happened is I just continued over here, just so I don't get in this one's way. But either way, I got what I need now. So I now have my solution. So again, make sure we put our x first. So that's going to be 2 and 8. So 2, 8. Close it in parentheses. There we go. So that's our solution that we got. Box that up. That way we know it's the solution. Whew, okay, so we got that one. All right, moving on to this one here. So again, step 1, we got to solve for one of these, and there's only 4 possible choices. Solve for this one, this one, this one, or that one. Those are the only 4 choices we have. And if we learned anything from the other one, if you already have a variable that is by itself, that's usually the easier one to do. And again, it doesn't matter. You don't have to follow these exact same steps. You don't have to say, okay, well, you pick the top one and move it to the bottom. No. Okay. Solve for one of them. In this case, this is the easiest one to solve for. And if I solve for it, all I have to do is add 7y to both sides. So plus 7y plus 7y. And that should get rid of this here. So x equals 7y equals 53. And sometimes, like in this case, we have to look for x first, right? X is the best one to solve for, just because, again, I cannot divide everything on this top by 7, and this bottom one cannot have everything divided by 4 or by 5. So since they can't be divided, it's going to be really hard. You can do that, but you're going to have to be working with a lot of fractions. All right, so now we have the top one. Let's take this bottom one and plug it in. So I'm going to go ahead and Okay, wouldn't let me pick it. All right, so negative 4x, but again, we're gonna plug something in there for x, minus 5y equals 19. So again, by doing this, by doing that, we're getting rid of one of the variables. We're getting rid of, in this case, x, okay? You cannot solve it. You cannot solve any equation if you have x and y together or any two variables, all right? If you find a way to do that, let me know and I can go get a Nobel Prize or something like that, but it's just not the way things work out. So we got to get rid of one of these. Oops, I accidentally made this into an equal sign when it should have been a plus sign. All right, so anyway, now, again, I put this one into that one. So there's my bottom equation, plug that in there. Now I should be able to get this solved. And again, I'm just gonna go ahead and do the normal stuff. So negative 28y. And then 4 times 53. It's gonna be 212. Minus 5y equals 19. Combine your like terms. So here I have negative 28y and negative 5y. Put them together, you would have negative 33y. And then I have negative 212. So 212, that means I'm gonna have to add 212 to both sides. So add that to 19 and I get 231. Excuse me. Okay, now I have negative 33y. So to get that negative 33y, I'm gonna have to divide both sides by 33. And that's gonna be y equals negative 7, because again, I have to divide by negative 33. But I have the first one now. We got our first variable. And again, this is just ordinary algebra. So please, 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 I hope you're good at that already. Because let's see, I'm gonna have to take this and I'm gonna have to plug it into one of these. Now again, I do have a choice on this one here. I'm gonna plug it into the top one. Okay, I'm gonna plug it into the top one because it's already solved for x. And if I plug it into this one, it looks like I'm gonna have to do a little bit more work. At some point, I'm gonna have to divide everything by 4 or 5, right? And that's just extra work. So again, you don't have to follow the same steps that I'm doing. You can pick and choose, but again, you just can't plug an equation into itself. That's like the only thing you can't do. All right, so let's see, x is, let's see, x minus 7, but we know that y is negative 7. X plus 49 equals 53. And in this case here, it looks like I'm gonna have to minus 49 from both sides. 53 minus 49. That's gonna be 4, so x equals 4. And there we go. So we should be able to write our solution now. So what is that gonna be? Negative 7, 4. No. Again, make sure you have your x value go first. So in this case, my x value is 4. And my y value, which was actually the first thing I found, is negative 7. So again, you got to make sure they're in the right order, because that is a very easy way to get the wrong answer and do all that work for nothing. Okay, so there we go. We got the solution for both of those. Let's go ahead and move on to the next thing. I think this is the last one. Yep, last one. So let's go ahead and do this. All right, so now looking at this one, it looks like we have a choice. Okay, I could either add y to both sides and then minus 5, and I'd have something like y equals 3x minus 5 or something like that. But remember, I told you that you can also look at something, and again, in this case, I have two really good choices. Neither of them looks like they're going to be better than the other one, but I'm going to do something we haven't done yet. Okay, again, I could easily solve for this y here. That's easy to do. So if you wanted to do that, if you see an assignment exercise and you think, okay, I'm going to do it that way, you can go ahead and do it that way. But I'm going to show you something else you can do. Not another way, but something else you can do. All right, so what I'm going to do is I'm going to divide everything by 2. So divide this by 2, divide this by 2, and divide this by 2. And the reason I'm not writing that every time is because I don't want people getting confused and thinking, oh no, do I have to write little numbers on all of these? No, you don't have to write little numbers on all of them. Okay, you just need to know what's going on. So again, I divided everything by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. And again, now I have a different equation. Well, it's not a different equation, it's just been reorganized. And now I have to take this one here and plug in here. So let's go ahead and take that and plug it in. So 3x minus y equals 5. But I'm going to take that y out, this y right here, and replace it with parentheses because I'm going to grab what we got from here and plug it in. So 3x plus 5 like that. Now these two look very similar actually. In fact, I'm kind of thinking something's going to happen here. So let's go ahead and distribute out. And again, don't forget when you distribute a negative, this negative means it goes onto the 3x and it goes onto the 5. So again, both of these things in here will switch signs. So positive to negative, so they will switch. Now I end up with 3 minus 3, which last I checked is going to be 0x. And if I add 5 to both sides, well, actually, I don't really need to do that. So we had our x drop out. So what happens when the x drops out? Well, remember, there are two possibilities. There can be all real number solutions, which is what I think what we did last week, or we could have, which again is that all real numbers is the same as infinite solutions in a way, or there can be no solution, but we got to check if it's true or false. So in this case here, this is a false statement. -5 is not the same as 5. So in this case here, this is going to be a no solution because it is a false statement. Now, if we wanted to, maybe if I have a little bit of time, we could probably, well, maybe I do have some time. So if I try this a different way, it should still be the same thing. So I'm going to do what I said I was going to do, and I'm going to make this. I'm going to add y to both sides, so I get plus y, and I'm going to minus 5 from both sides, so that I get 3x minus 5. And if I were to take this and plug it into the other one, so I'm going to plug it into the top one. So my top equation is going to be let's see, 2y, but I know in this case it's going to have to be 3x minus 5. Equals, no, 3x equals 5. Oh, it is equals 6x plus 10. And I'm pretty sure this is also going to be no solution, but I'm just showing you that you can do the other thing. You can do like an opposite type thing. So that'd be 6x minus 10 equals 6x plus 10. And if I did this, you'd notice that I'd have to minus 6x from both sides, and the x would still drop out. I would still lose the x value, and I would get something along the lines of negative 10 equals positive 10, which in this case is still false and still no solution. But again, I hope the only thing I wanted to point out with that was that you don't have to do the same steps I do in order to figure it out, all right? You don't have to do the exact same steps. You can do it your own way. All right, so let's do this last one here. So looking at it, let's see, I can't divide everything by 5 on the top, but I also can't divide everything by 7, so that's not gonna work. Here I cannot divide everything by 4, and I cannot divide everything by 3. So I'm really gonna have to pick one to do. And there's not gonna be an easy way to do this, okay? There is not an easy way to do this. So it looks like I'm just gonna have to pick one. And for this one, I'm gonna just pick the bottom one and I'm gonna solve it for y, okay? Which is, it's gonna be messy. So it means I'm gonna have to minus 4x from both sides. So I get negative 3y equals negative 4x minus 5. And then I'm going to have to divide everything by 3. So divide everything by 3. And now I should be able to get y by itself. So y equals negative divided by negative is positive. And I end up with fractions. And again, I don't know if this is the best way to do this. I just picked one, okay? Just at some point like this, you don't want to agonize over your choices and be like, oh, should I have done this and should I have done that? No, let's just get it done with. Okay, let's just keep moving forward. So I'm gonna have to take this one here and plug in for y. So 5x plus 7y. But in this case here, this is gonna be, I'm going to plug this in there. So 4 over 3x minus 5 over 3. And keep writing this, negative 17. And again, I don't know how this is going to work out. 5x plus, and then 4 times 7 is 28. So it looks like I'm going to have 28 over 3 for this one here, 28 over 3x. And then 7 times 5 is 15. Leave the bottom number the same, equals negative 17. Now for this one here, I'm thinking of, because we have fractions, okay? Because we have that big set of fractions, what I'm going to do is I'm going to multiply everything by 3. So look at your bottom numbers. Look at those bottom numbers and think, okay, well, what can I get out? What can I get rid of in all of this? So pick a bottom number and look at your bottom numbers and pick a number that can be divided by all your bottom numbers. So in this case, 3 can be divided by 3 in both ways. So I'm gonna triple everything. So 5 times 3 is 15x plus 28x minus 15 equals, and then 17 times 3 I think is 51, but I'm going to double check that. Yeah, it is 51. So now I have no more fractions, which is probably a good thing. And now I have to do 15 plus 28, which is 43, oopsie, 43x. And then I'm also going to add 15 to both sides. So, ooh, gosh. gonna be 36. Okay, it's negative, negative. So I'm gonna have to add them. That would be negative 36. No, wait, hold on a minute there. This is supposed to be 35. 7 times 5 is 35. That would make this 35. And 51 minus 35, that would be, they'd both be negative. And divide both sides by 43. X equals negative 2. All right, and that hopefully that works. Because I'm gonna have to plug one of these back in. So let's go ahead and get that done quickly. So 5 times negative 2 plus 7y equals negative 17. And let's multiply that out. Add 10 to both sides. And that'd be 7y equals 7, no, negative 7. Yeah, negative 7. So that would be y equals negative 1. All right. Whew, man, okay. I was trying to hurry through that last one. I knew the bell was coming. Well, actually, I shouldn't circle it because in this case, the circle is just telling me that's part of the answer. That's why I use box. So box that up. All right, so there we go. So hopefully that one wasn't too confusing, but it kind of was because of all those fractions and negatives and stuff. So make sure that sometimes you just got to realize that there's just going to be a lot of work on some of these. And again, fractions are one of those things you're just going to have to get used to because they're not going anywhere. There's going to be fractions everywhere, right? Sometimes you'll just never be able to get away from them. Anyway, so that's it for today. I got to get ready for my next class, so I will see you guys later. Bye for now.